Question number 6 says a poster is to have 180 square inches of area with 1 inch margins at the bottom and sides and 2 inch margin at the top. What dimensions will allow for the largest printed area? Justify your answer. So, what we're going to have is a rectangular poster with a frame around the outside from the margins. So, what we know is this: we have 1 inch margins at the bottom and on each side, and a 2 inch margin on the top. So that means we're going to have the known area be the whole poster. If the known area is the whole poster, we're going to call this X and this Y and work inward to the other ones. So that means the width is going to be X minus 2 and Y minus 3. So now from there, we can go ahead and work out our problem. We always want to set the X and the Y, the basic versions, to the part of the shape we know, because that's going to make our area easier to work with. So our area is just going to be X times Y equal to 180. By choosing the easier dimensions, this becomes the easier part of the problem. Now, the thing we're trying to maximize, because we want the largest printed area, is going to be X minus 2 times Y minus 3. So we're going to start by rewriting this first equation to something like X equals 180 over Y. It doesn't matter, again, which way you solve that. So it's going to turn into 180 over Y minus 2 times Y minus 3, which now we need to simplify that before we can actually do our derivative in things. 180 over Y times Y is 180, minus 3 times the 180 is 540 over Y minus 2Y plus 6. So now that is going to be our function. From there, we're going to go ahead and find our derivative. Our derivative is going to equal the 180 and the 6 go away. Negative becomes positive 540 over Y squared, and negative 2Y becomes minus 2. So my critical values are what would make this 0 and undefined. Well, undefined would be 0, so we don't need that critical value because Y can't be 0. So we just need to know where 540 over Y squared equals 2. So rearranging that, Y squared is going to equal 270. So Y is going to equal plus or minus the square root of 270. Now, to figure out X, we're going to go ahead and plug back into our original problem. So we can say Y or X is equal to 180 over the square root of 270, which is going to give me 180 times the square root of 270 over 270, which is not as bad as it looks. That actually reduces. Those both have 90 in them. So it is just 2 square root of 270 over 3. The square root of 270 actually has a 9 in it, so I could reduce that even further. So I'm going to go ahead and get that down to Y being, let's see, if we take out 9, 2 square roots of 30. So then from there, I'm sorry, that's the X value. We have our X, we have our Y. So from there, we can go ahead and justify whether or not our answer is correct. So second derivative is off of the first derivative, negative 1080 over Y cubed, which when we plug in a positive value for Y is going to end up less than 0, which is going to end up concave down, which is going to produce our maximum. So all we need to do now is make sure we answer the question, what dimensions? So our dimensions are going to be 2 square roots of 30 inches by the square root of 270 inches. And that is the answer to this one.